All right, Sign Lingo, you're up. You guys should be able to unmute and share. Let me know if you can't.
Okay, thumbs up. I'll go ahead and share my screen to get us started. Here we go. So hello, everyone. We're the Sign Lingo team. Kendra doubled as our stakeholder and UX designer. Michael was our team lead. Wesley, Cooper, and Ryan were our data science team members. Chris, Brian, Natalia, and I were the web team. So Sign Lingo is an app to learn sign language. Before Sign Lingo, a lot of the apps and things to learn sign language are dated or otherwise blocked behind a paywall. So we wanted a fun, easy to use, and free way to learn sign language.
So before a new user is able to start using Sign Lingo, they'll first need to be onboarded. We're using Okta so that we're not storing any sensitive information like the user's email or password on our end, and it's also being stored on Okta's side. Since Okta has a drop-in widget, we were hoping that it would be easy to implement, but the variety of flows and the level of abstraction that Okta has over what it's actually doing turned out to be what I think was the biggest challenge for us.
Right. Now, as you can see, we logged into the dashboard. So Sign Lingo contains 5 levels, each representing 5 to 6 letters of the alphabet. A level is made up of 3 sections: flashcards, exercises, and quiz. So let's begin learning by entering the flashcards section. This is where users can become familiar flipping flashcards to learn the signs of that level. Users must click each flashcard from that level to be able to progress, and once they feel confident enough, they can click finish and return to the dashboard.
After you're done with flashcards, it's time to practice some exercises. You'll notice a progress bar on top showing how far you've gotten, as well as the number of lives you have left. If you got a question wrong, you lose a life. If you lose all your lives, you'll have to repeat the exercise before moving on. The last part of a level will test the user's competence in signing what they've learned. The user will grant access to Sign Lingo to use camera in order to send video to Data Science API to assess for accuracy. The Data Science API will respond with a result, and the next question can appear. If a user passes every question, they can move to the next level. Now let's hear from our data science team about their model.
So to understand the direction that the data science team decided to take, it's important to recognize a few things. First off, sign language is more complex to model than other forms of natural language. It's what is called multi-channeled, meaning that meaning can be conveyed not only through the hand shape, but through the position relative to the body, facial gestures, speed, and even throughout multiple signs. Secondly, after researching more complex forms of modeling that could capture these other elements, we found that it would have been much more complex to implement these, and even then, the performance of the state-of-the-art wasn't to a point where it would be user-friendly enough. And thirdly, we are also teaching in a more modular style where we have like these alphabet lessons and number lessons. So, and then finally, due to the lack of available large-scale annotated data sets, we thought that we would use a more unconventional approach, and that is being object detection. So before we get more into the model, Wesley is going to briefly talk about our stack and some of the problems we faced.
Yeah, so as for the tech stack that data science is using, we deployed a Flask API in Docker to AWS Elastic Beanstalk. The model predictions on the API side are handled by a darknet implementation of TensorFlow in OpenCV. It was necessary to use FFmpeg for reading of video metadata to ensure proper orientation of the input images as mobile data comes in sideways by default. So both OpenCV and FFmpeg made it necessary to use Docker during deployment.
And then obviously the biggest issue and a very common thing that data science runs into is data. Labs 22 had the Kaggle data set, which had a significant amount of data, but it wasn't diverse enough. So with the combined effort of the entire team, we took about 11,000 photos of ourselves and then processed all of it hand annotated. I'm not sure if any of the data science people are familiar with labeling, but we use binding boxes for labeling, which is a very tedious process. I estimated it took us just annotating alone to be about 13 hours worth of annotations. But as you can see, after I think the model was trained for roughly 50 hours, but it's performing very well. Jackson that is not a video, that is a live feed. If you could maybe do an incorrect one or a correct one for us real quick. Let's do a W. Yeah, there you go. And then as you can see in the console, it grabs 3 frames currently, just to kind of make sure that it has enough time. It predicted all V's, not very well. Well, I guess the last V was good, but V is the peace sign, so you can see a W and a V would be roughly the same. If you could do a correct one though, we chose I think Wesley went over it real quick. It's a TensorFlow model. This one in particular is a little lighter weight. It's only about 23 layers of convolutional neural network. That is Sign Lingo for you.
That's awesome. This is another really, really awesome example of how software is kind of moving things forward. There's when you think about learning, there's learning, so sort of from a book or from just sort of static resources. Sort of next level up is kind of video. Next level up is in-person training and teaching, but in a classroom context. And then obviously having one-on-one expert training is the highest. But that's also you look at those things. That's also cost. The ramp of cost, right? So the cheapest is just to publish a book or something static like an ebook or something, all the way up to sort of one-on-one personalization. But this technology is the equivalent of, or can be the equivalent of one-on-one training, where you're actually getting immediate feedback. You're not imagining somebody correcting you. Somebody's actually correcting you, and potentially even better than a human could. Faster than a human could if you were assigning really fast, right? If you were working on training to be, a sign linguist, an annotator for speeches or something, if you could get this thing to go really fast, you could, basically spell check or check somebody's work as they're signing really fast, probably faster than only like the best, sign lingo or sign linguists could do. And so it's awesome. It's technology shifting into a position that can move something that's somewhat esoteric. It's not a super mainstream thing, but we can do it and we can make an impact in that world, which again makes the world a little bit better. So really awesome to see. Really awesome to see all these technologies come together. I know there's always limitations in labs. Cost being one of them, and that's a big one, right? So if we had, the budget, we could have hired, a bunch of people to go do this. That's what happens with a lot of, annotation jobs, is you just hire, 100 people just to sit down and annotate stuff. And that way you can get volumes of data, which will be better training. Or if you're Google, you can just present them to people in CAPTCHAs, and then they can do all your training for you. Maybe someday we'll see Google doing CAPTCHAs with sign language, and they'll have a really awesome killer training set from that or something. And then also just from the volume of data, right, and how much processing time you can put into it, et cetera. And you've also got limits because this is live. And that's one of the big challenges with data science. Doing data science in batches, you can do a lot more because you can run your batches for hours and hours or weeks if you need to. You can run them off hours when things are cheaper. But if you're doing something like this live, you've got very specific limitations. You have to, come back and give the user a response really quickly. And so that's a big challenge. And so balancing, processing power and data and cost and everything is actually part of, the data science discipline, and is really part of the software discipline, because the same thing applies on the software level, right? Is you can imagine all sorts of crazy things you can do, but if 90% of your customers don't have a machine that can pull it off, think about gaming, think about just things happening in your browser, all the limitations. There's a lot of limitation and constraints that are kind of built into what we do every day in software. And a lot of times it becomes a balancing act from your imagination as an engineer saying, we can do this, and then the finance person saying, yeah, but we don't have $10 million. So we got to figure something out. And
to piggyback off of that a little bit, we actually, because of the financial constraints, ended up having to use Google Colab for 100% of our training, which became a huge issue in terms of time constraint and ability to mount the data and everything like that. It was a massive hurdle because SageMaker on Amazon Web Services gets very expensive very quick.
very expensive,
So.
very quick, yeah, no doubt. But there's also a lot of mitigations for that. Within Amazon, there's lots of ways to get cheap compute time. There's lots of ways to, you know, but it takes investment of time and effort and, you know, sort of just practice to start using, you know, spot instances and stuff, or reserve instances. It's a whole thing. It's a whole nother layer. But, you know, and this is what we really try and teach in labs, is that writing software is not just sitting in VS Code or Eclipse or whatever and writing code. It's like all of these other things, right? Everything from UX all the way down through, you know, the financials of it and being able to work within constraints. And that's a big part of it, because you're always going to have constraints regardless of where you end up. If you end up at Facebook and you've got a huge budget, you'll still end up with constraints. If you end up at a startup with a really small budget, or a nonprofit with an even smaller budget, you're still going to have constraints. And so understanding how those constraints work and operating within those constraints is a really key skill for a developer. So hopefully everybody has taken some time to pay attention to that and learn from it.